Now the fifth sum. Already is given there. I've drawn the figure. P is the center of the circle. AB and CD are the chords which intersect at point E. And these two angles AEP and angle DEP are congruent. And we have to show that these two lengths AB is equal to CD. That is what we have to prove. So over here we'll write on the given part. The first point, it is given P is the center of the circle. Second, chord AB and chord CD intersect at point E. Third, it is given angle AEP is congruent to angle DEP. And we have to prove that chord AB is equal to chord CD. This is what we have to prove, that they are equal. Now here, construction. You can prove it in two ways, boys. One is angle bisector theorem and the other way is by taking the two triangles. So I will show you by taking two triangles. So here, draw PM perpendicular to AB. So I am writing here, draw PM perpendicular to AB such that A dash M dash B and next one is draw PN perpendicular to CD and PN perpendicular to CD such that, this is very important, such that C dash and dash D. This is the construction. So as a result, we are getting two triangles, that is PEN first triangle and PEN is the second triangle. So we are getting two triangles. Proof. In triangle PNE and triangle PNE. Always I told you there are three statements and you have to write down the reason along with the three statements. The first one is both the triangle they have a common side, that is PE. We got one statement. Second statement is PME is 90 degree and PNE is also how much? 90 degree. So you got second statement. Third statement. Now it is given AEP that these two angles are congruent. That is given. So you got three statements. So as a result, both the triangles are congruent by SAA. SAA test. So naturally what will happen? Then you will get your PM is equal to PN. Okay. So now we are writing down the three statements. The first one, PE segment PE congruent to segment PE, common side. The reason is common side. Second, angle. Now this angle PNE is congruent to angle PME, each 90 degree. Third statement, instead of saying AEP, you can say MEP because the angle remains the same. So angle MEP is congruent to angle. Instead of saying DEP, you can say NEP because angle remains the same. NEP. And then you write down here given. Because angle is the same. See here E and here also E. Angles are same. Now you got the three statements. Therefore, after in come therefore triangle PNE is congruent to triangle PME by SAA test. So naturally you get PN equal to or segment PN, you can write on segment PN is congruent to segment PM. It is corresponding sides of congruent triangles. So when these two sides are congruent, so you must remember the theorem what we did. So in that case, when these two sides are congruent, meaning the two chords are also equal. So therefore, that means chord, you can say chord AB is congruent to chord CD. The reason is the chords of the circle, this is a theorem what we have done, the chords of a circle equidistant from the center of the circle, equidistant from the center of the circle are congruent. In other words, I'll just draw the figure. The theorem what we have done is, last time we have done the theorem AB and CD. These are the two chords. And this is O is the center. If you say OP is equal to OQ, if OP is equal to OQ, naturally AB is also equal to CD. Because these are perpendicular ones. So when OP is equal to OQ, meaning AB is equal to CD. That is, the chords of a circle equidistant from the center of a circle are congruent. So if this distance OP is equal to OQ, then AB is also equal to CD. Same thing it is. If PN is equal to PM, so in that case AB is equal to CD. I hope this is clear to you boys. So this sum is over. You can write down therefore AB is equal to CD. This way also you can write it. When you are writing equal, then don't write here chord. If you are writing chord AB, then you write a congruent.
Yeah,